Hello and welcome to another video on chemistry tips and techniques. This is Mahdi and welcome to my YouTube channel, Chem with Mahdi. Before proceeding to the lesson, I would love to ask you to please subscribe to the channel and like the video if you find the channel and the content helpful, and also please share it with others as well. Thank you very much for the support. That's going to be a great support actually. In this video, I'm going to teach you the technique how to write the electronic configuration of the metal ions. So if you browse my YouTube channel and go through the playlist, you will see some videos that I explain how to write the electronic configuration of the neutral atoms and specifically the transition metal. And in this video, I'm going to focus on how to write the electronic configuration of their metal ions. So we're going to focus on elements from scandium with atomic number of 21 up to zinc with the atomic number of the 30. So as you can see, I already provided you with the electronic configuration of the neutral atom. For example, in this case, you can see scandium has been given to you. So the electronic configuration of scandium is argon 3d1 4s2, and scandium creates this cation or this ion, which is scandium 3+. So how can we write the electronic configuration of a scandium 3+? We need to realize what happened to scandium. So the scandium has been converted to scandium 3+. So as we can see here, in this process, 3 electrons are taken from the scandium. So in other words, scandium has lost 3 electrons. So the technique is very easy. We have the electronic configuration of a scandium. We just need to remove 3 electrons from this electronic configuration. But how can we remove the electrons from this electronic configuration? The task is very easy. You just need to first remove electrons from the 4s subshells and then, if necessary, from 3d. Please don't forget this order. First, you remove the electrons from 4s, and if necessary, you remove electrons from 3d. For example, in this case, I'm going to remove 3 electrons from scandium. So I will start with the 4s. The 4s, as you can see here, has 2 electrons. So I'll remove these 2 electrons. So 4s will become 4s0. That will be empty. And then you will remove this 1 electron in 3d subshell. That will become 3d0. So both of these subshells, 3d and 4s, will become empty, and you will be only left with the electronic configuration of the argon. So that's going to be the electronic configuration of scandium 3+. It's going to be only argon. Let's move on to the next one, titanium. So this is the electronic configuration of titanium, argon 3d2 4s2. And for titanium 2+, what has happened from titanium to titanium 2+? Titanium has lost 2 electrons. And then we're going to remove 2 electrons from this electronic configuration. So as I just mentioned, please be aware of the fact that you need to give the priority to the 4s. So if you're going to remove only 2 electrons, you will remove it from 4s. And 4s2 will become 4s0, and you will be only left with this part. So the electronic configuration of titanium 2+ will be argon 3d2. Look at the vanadium. We have a specific case. Vanadium is one of those transition metals that makes more than one type of ion. So vanadium can make vanadium 2+, or it can make vanadium 3+. So to write the electronic configuration of the vanadium itself is 3d3 4s2 and vanadium 2+. So we have to remove 2 electrons. So 2 electrons will be taken off from the 4s. We will have argon 3d3. And for vanadium 3+, again, we compare it with vanadium. From vanadium to vanadium 3+, we need to remove 3 electrons. So 2 electrons from 4s will be removed, and we need to remove 1 more electron, which is going to be removed from 3d. And 3d3 will become 3d2. So we will have argon 3d2. Chromium, as you might remember in the previous lessons, chromium is one of the exceptions of the Aufbau method when we are writing the electronic configuration. So the actual electronic configuration of chromium is 3d5 4s1. So chromium can make 2 different cations, as we can see here, chromium 2+, chromium 3+. Now to write the electronic configuration of the chromium 2 plus, so we have to remove 2 electrons. So 4s1 only has 1 electron, so this one will be removed, and we also need to remove one of the electrons from the 3D, so 5 will become 4. So it's gonna be argon 3d4. And what about the chromium? We should take 3 electrons from the chromium. Again, looking at the electron configuration of the chromium, so 1 electron will be removed from here. We need to remove another 2, which 5 will become 3. So it's going to be argon 3d3. Now, I would love to ask you to pause the video and try to work on the rest of them, and then just compare the cations with the original atom over here. It's going to be minus 2 electrons, same thing, minus 3 electrons. And then you can also compare with the proper answers that I'm going to put in the rest of the video. All right, I also put a link to the PDF file that contains all the examples and tips in this lesson. You can also download the PDF file, you can revise it, and you can also use it for checking the accuracy of your answers. And please subscribe to the channel and like the video if you found the content helpful, and you're most welcome to share it with others as well. I'll see you in the next lesson.